Atacama Oases. It's not about what you see, it's about what you hear, so you can truly understand. Just 1 second of your time to subscribe could help us bring you even better content every single day.
How on earth did someone 1,000 years ago manage to calculate the size of the Earth without ever stepping foot into space? How did they measure the height of mountains without any modern gear? How did they pin down the locations of cities and stars with such mind-blowing precision? That's what we're going to figure out together on a journey with a genius from an era that didn't have any computers or satellites, but who used his brain and the laws of mathematics to unlock the secrets of the universe all around him. Abu Rayhan Al-Biruni was a true polymath who was born back in 973 AD in Khwarizm. He had such a unique way of thinking. He wasn't just satisfied with abstract theories, he insisted on running the measurements himself. By blending super-precise observation with math, he was able to turn natural phenomena into actual numbers that could be calculated and understood. For example, to measure the Earth's circumference, he didn't hop on a ship or trek across massive, endless deserts. He came up with this genius method that relied on measuring the angle of the horizon's dip from the top of a mountain. The idea was simple at its core. The higher you get above the Earth's surface, the more the horizon appears to dip below the horizontal line, and that dip actually reflects the Earth's curvature underneath you. As for how he figured out the height of the mountain itself, Al-Biruni would pick two spots on flat ground with a known distance between them, then measure the angle between the ground and the mountain's peak from each spot using an astrolabe. Using those two angles and the distance between the points, he was able to use trigonometry to nail the height of the mountain with incredible accuracy. After he figured out the height of the mountain, he climbed right to the top and measured the angle at which the horizon dipped below the horizontal line. With those two pieces of info, the mountain's height and that angle of dip, he applied a simple geometric rule. The relationship between the Earth's radius and the mountain's height depends on the cosine of the dip angle. Just like that, he calculated the radius of the Earth. He then put his method to the test in a mountainous region about 100 kilometers from present-day Islamabad, Pakistan. He calculated the Earth's radius to be 6,338.80 kilometers. The value accepted today is about 6,371 kilometers on average, meaning his error was barely around 1%, a totally mind-blowing achievement for 1,000 years ago. Al-Biruni didn't just stop at calculating the size of the Earth, though he also used his knowledge of the sun and stars to nail down latitudes with insane precision. He'd measure the altitude of the sun at high noon in a specific city, which would tell him exactly how far that city was from the equator. By doing that, he was able to map out the locations of cities across the globe with total accuracy. Figuring out longitudes was definitely tougher, but Al-Biruni came up with a genius terrestrial method for that too. It basically relied on measuring the shortest longitudinal distance between 2 points, knowing the latitude of each, and then calculating the differences in longitude by tracking the timing of sunsets. With this method, he linked far-off cities together into one massive cohesive geographic network. For example, Al-Biruni mapped out parts of Central Asia and India with crazy precision. He'd log the exact spots of cities, rivers, and mountains based on his astronomical observations. These maps weren't just drawings, they were the product of some seriously complex mathematical calculations that made them light years ahead of anything else floating around in his time. As for astronomy, Al-Biruni penned Al-Qanun al-Mas'udi, which is basically the ultimate encyclopedia of medieval astronomy. It featured 11 articles split into a whopping 142 chapters, covering every single astronomical observation known back then. That book was the go-to reference for astronomers for centuries on end. If we take a look at his book, Kitab al-Tafhim, we find it's written in this awesome Q&A format breaking down arithmetic, geometry, algebra, and astronomy. He even packed it with diagrams and illustrations to make it super easy for the reader to grasp those tricky, abstract concepts. This whole teaching style was honestly way ahead of its time. Al-Biruni even tackled the idea of the Earth rotating on its axis. He explained that the Earth spinning in front of the Sun every 24 hours is exactly what determines the appearance and disappearance of stars in the night sky. This concept was way ahead of his time, as it didn't really become widely accepted until centuries later. Al-Biruni used the astrolabe with such high efficiency to measure angles. This simple device, which kind of looks like a protractor, was capable of solving super complex astronomical problems. He used it to measure the altitudes of stars and planets, and nail down specific times with total precision. For him, the astrolabe was basically what the computer is for us today. Al-Biruni absolutely refused to accept any info unless he could back it up with a solid mathematical proof or direct observation. This super strict scientific approach is exactly what helped him lay the groundwork for comparative civilizations and mathematical geography. He wasn't just a messenger passing on knowledge, he was a total producer of it, constantly testing out hypotheses and correcting mistakes as he went. And that's how we see that Al-Biruni's genius wasn't just about memorizing facts, but about his ability to spot the hidden connections between phenomena. He turned simple observations into mathematical equations and modest measurements into cosmic knowledge. He proved that the human mind, when used properly, can measure what the eye can't see and understand what the hand can't touch.